So today we're going to talk about conservation of energy. What if I were to ask you the following question? We drop a ball from a certain height and it reaches the ground with a velocity of 10 meters per second. How could we resolve that? All we know is our terminal velocity, which would be 10 meters per second. They've not given us the mass of the ball, etc. And we're asking, from what height was this ball dropped? So basically, our question is the following. If we drop a ball and it lands on the floor with a terminal velocity of 10 meters per second, what was our height? We're assuming that since it was dropped, we have an initial velocity of 0 meters per second. So for this we can actually use conservation of energy, whereas here the ball with no movement would have only potential energy, whereas here when it touches the ground and it has no height, we would have kinetic energy. Now, due to the laws of conservation of energy, we can say that potential energy will be equal to the kinetic energy during phases 1 and during initial and terminal phases. Okay, so we know our formula for potential energy. This is equal to the mass times the acceleration of gravity times the height, which is what we're trying to figure out. And for kinetic energy, the formula is 1/2 mass and the velocity speed, basically the difference in velocity. Now, if you notice here, a lot of students freak out because they say, "Miss, we don't have the mass of the ball." So would this be the same for a heavy ball or for a light ball? If we're assuming that there's no air resistance, yes, it should be. Because if we notice here, we have mass on both sides of the equation. So in this case, we can eliminate the masses. Now this makes things much more simple, because when you have only one data in your question, such as this, one tends to think that we're missing data. So basically, we can cross them out. This will leave us with an acceleration of gravity of 9.81, which we already know, the height, which is what we're trying to figure out, and 1/2 of our difference in velocity is squared, which would be 10 squared. Okay, so if we put this together, we have 9.81 height equals 1/2 of 100, which would be 50. That would leave us with a height of 5.1 meters. So you see, with only one data, our final velocity, we could be able to calculate the height at which something was dropped, and vice versa. If we have the height at which it was dropped, we can find its terminal velocity. So it's very easy to transition between these two different states, where we have only pure potential gravitational energy, and here only pure kinetic energy. Here things are a little bit more complicated. We have a mixture of energies, because the ball is moving and it has a certain height.